Assalamu alaikum. What is the velocity of free electron inside the conductor? Imagine this is a conductor connected to the positive pole of the battery and this wire connected to the negative pole of the battery. When we connect that wire to the conductor, we have here a potential difference between the positive side of the conductor and the negative side of the conductor. That electric field causes the free electron move from negative side to the positive side of conductor. But the conductor is solid, not hollow. So the conductor fill of atoms. So inside the conductor, the free electron collide with the atoms of conductor. The free electron inside the conductor move randomly, but because the electric field moves slowly in direction to the positive side of conductor. But we talk about billions of free electrons. So we say mean drift velocity. Mean, it means the average velocity. Drift, it means it is not in a straight line, it is a zigzag. Now, this is a conductor. That conductor, most of conductor are cylinder. The cross-section area of cylinder is a circle. So this is a free electron. The free electron move from the negative pole of the battery to the positive pole of the battery. This is the definition. The definition is outside the syllabus. Drift velocity can be defined as the average velocity attained by electrons in a material due to the electric field. Now we need to produce the velocity of free electron inside the conductor. Imagine this is a conductor cylinder of cross-section area A, and the length of conductor is L. What is the volume of that conductor? So the volume of that conductor denoted by V, which is AL, the cross-section area multiplied by the length of the conductor. Let N is the number density of charge carriers per meter cubed of conductor. Each conductor has N. N, it depends on the type of conductor. So N is the number of free electrons in 1 meter cubed of the conductor. But this volume is not meter cubed, it is a part of meter cubed. So the number of free electrons inside that volume, so the number of free electrons or charge carriers in that volume is the volume AL multiplied by N, because it is a part of meter cubed. The charge of each electron is E. So the total charge of charge carriers in that volume, so the total charge in that volume denoted by Q equals the number of charge carriers in that volume multiply E, the charge of each electron. Let this equation number 1. Imagine the electron has drift velocity V and it moves from one side of conductor to the other. The length of conductor is L. The velocity of that free electron denoted by V equals the distance over the time. The distance is the length of conductor, so it's L. The time from one side to the other side, T. Rearrange this equation to get the time. So T equals L over V. This equation number 2. We know that the current equals the charge over the time. So the current I equals the charge Q over the time T. From equation 1, the charge is A L N E. From equation 2, the time is L over V. Now, we can cancel L with L and flip V upward. So, the current equals A N E V. A N E V. From this, we can rearrange it to get the drift velocity. So, the drift velocity equals I over N A. If the conductor is uniform, so the cross-section area is constant. For any conductor, N is constant and E is constant. So the drift velocity, V, is proportional directly to the current. If the current is doubled, the drift velocity is doubled. Remember the unit. Drift velocity measured in what? Drift velocity measured in meter per second. N, it is a constant, it depends on the conductor. It is the number of free electrons per meter cube. So it is the number of free electron per meter cube. A is the cross-section area. If the conductor is cylinder, the cross-section area is a circle. The area of circle is pi r squared and its unit is meter squared. E is the charge of electron. It's constant, 1.6 times 10 power negative 19 coulomb. I is the current in ampere. Take care the difference between the unit of current and the area of conductor. A down in the denominator is the cross-section area, but the unit of current denoted by A. Take care, don't confuse. Now let us solve a question about this topic. Now, we read the question and we write the given. Okay, here. So, yeah, we read the question. The average drift speed or velocity is, so we have given V. V equals 6.5 times 10 to the power negative 4 meter per second. When the current, this is I, so the current is 0.80 ampere. The diameter of the wire, take care. This is the diameter, it is 0.50 millimeter. We need to convert to meter. So from millimeter to meter, multiply by 10 to the power negative 3. And also we need the radius. Remember the circle. This is a circle, okay? So the circle has diameter. What is the relation between the radius and the diameter? The radius of the circle is half the diameter. So the radius of that circle is half multiply 0.5 times 10 power negative 3. We calculate the radius of that conductor. So it's half multiplied by 0.5 multiplied by 10 to the power negative 3. So the answer is 2.5 multiplied by 10 to the power negative 4 meter. Now we can calculate the area. The area or cross-section area denoted by A, it's by r squared. Okay. So it's by r squared. Pi is constant, r is given now 2.5 times 10 power negative 4 all squared. Now we're squaring the value. Okay. So it's by open bracket 2.5 times 10 to the power negative 4 close the bracket square. The answer is 1.96 times 10 to the power negative 7. 1 0.96 multiply 10 to the power negative 7 meter squared. What do we need? He said calculate the number of free electrons per meter cubed. We need N. To get N, we go to the formula. The formula is that I, the current, equals N A E V. From this, rearrange, so N, the number of free electrons per meter cube, equals I over A E V. So N in that question equals I, which is the current, it is given. The current is 0.8 ampere, 0.80, and the cross section area, it's 1.96 times 10 to the power negative 7, multiply E, the charge of electron, 1.6 times 10 power negative 19, multiply the drift velocity, it's a given, the drift 6.5 times 10 power negative 4. One comment about this velocity. The drift velocity is very small. Why? Because I said before, the electron inside the conductor, the free electron, collide with the atoms of conductor. So it's very small. So it is in that question 6.5 times 10 power negative 4. 6.5 times 10 power negative 4. We use the calculator to get this value. 0.8 divided by 1.96 times 10 to the power negative 7 multiply 1.6 times 10 to the power negative 19 multiply 6.5 times 10 to the power negative 4. The answer here is 3.92 multiplied by 10 to the power 28. What is the unit? Free electrons per meter cubed. So it's free electrons per meter cubed. I hope you understand this lesson. Thank you.